For our project, we use a combination of manufacturing methods to create a timeless tool, the hammer. To create the hammer handle, we use the turning method. In order to stay safe during this method, we made sure to wear a respirator, closed-toed shoes, safety glasses, and made sure not to have any gloves or loose clothing around the machine.
We started with a 10-inch blank of red oak, marked the centers, and then mounted it on the lathe to begin turning into a rough cylinder. While doing the turning, it's important to keep the tool parallel to the ground and your hand on the tool rest to stay stable throughout the cut.
So at this point we have our 10-inch handle for the hammer. The next step is to begin to apply more pressure so that we can customize the handle grip to ensure comfortability. Notice that the lathe is spinning smoothly to make sure that there are no imperfections as we begin to apply more pressure. Here we are curving off the end of the hammer and preparing to cut off the part that is attached to the tailstock. This is our sanded, finished product. We then add a clear protective coating for aesthetics and comfortability.
Now that the handle's complete, the next thing to do is to start on the blank for our sand casting. So we started with a big block of cedar, marked out a rough hammer head, and began cutting it with a jigsaw. At this point, it's important to secure it with a clamp so that it doesn't vibrate or move around while cutting.
The initial cut resulted in this side and top view of our pattern. Grayson then clamped it down again, cut out the claw from the back end, and moved forward with grinding and curving out the rest of our pattern. The final design shape looked and fit as follows.
Now onto the part that we're all much less familiar with. So we've got our materials, we've got steel for the crucible, we've got stuff to make DIY polymer sand, and of course the aluminum to cast with. So first step was Grayson drilling holes in our foundry.
Here Riggs is fueling and lighting our foundry. You can notice that he is wearing his protective gloves. Here Peter is prepping the aluminum, which we are using due to its lower melting point than that of our steel foundry.
A huge safety reminder when doing a foundry at home is to conduct it on a non-flammable surface. Due to the holes in our foundry, the forced air from the hairdryer, and the bricks lifting and aerating our foundry, we were able to get the aluminum to start melting.
Moving forward with setting the drag and imprinting. Here you can see Sarah is applying pressure to our polymer sand to show that it will hold its shape when you do so. Here Sarah is imprinting the pattern into the drag. She then seals and fills the drag all the way to the top, making sure that the pattern is fully covered, and then removes the pattern to leave an imprint into the drag.
Here we begin to pour our molten aluminum into the imprint. The aluminum has to reach a temperature of 1211 degrees Fahrenheit in order to become a liquid.
Here, Jet notices that the aluminum had started to cool rapidly, thus not allowing us to pour. This caused us to deviate from our report procedures.
After running into this issue, this would have been our final product.
After coming this far in the project, we didn't want to stop without a finished product. Here you can see we took the aluminum scraps left in the paint can that had solidified and tried to melt them on top of the imprint. Here we're mixing the aluminum around with a steel bar. We try to get the cast as close to the pattern as we could. Here's the comparison.
After removing the casting from the drag, we used a grinding and Dremel method in order to smooth out the head. During this step, we used the Dremel to ensure that there are no clearance issues when installing the head of the hammer onto the handle.
For the assembly, Joey wedges a splinter into the handle to ensure a snug fit of the hammerhead. Hey, it may not look pretty, but the definition speaks for itself.
We learned really quickly to not underestimate how fast the cooling process can be. Always have a spare crucible to repeat the same melting process if issues arise, and that procedures can only improve after putting them to the test. Overall, sandcasting just really isn't as easy as it seems.